Keep her steady, watch the incline.
Engine performance is lagging on this grade.
And the track tension seems off. Look at the dust being thrown.
Track linkage, 42 millimeters.
42. Recorded. Check the road wheel stress next.
All observers ready. On the tank's movement, mark, go!
1,000, 2,000, 3,000, 4,000, 5,000.
The reports indicate recurring issues with the track mechanisms.
We've noted the same faults on Detachment B. The grease guns aren't enough.
It's completely inadequate for this terrain. The tracks are shedding mud. Agreed. The weight distribution is off. Mark it down.
September 1940. Aberdeen Proving Ground, Maryland. The air smells of hot oil and dry dust. An American tank lurches forward across uneven ground, its engine straining, its tracks clattering like loose chains. The steel is thin. The gun is modest. The crew inside sweats in silence, listening for sounds that would never come in training. Impact, penetration, fire. Across the Atlantic, tanks do not move like this. They move in formations. They break lines. They decide battles in hours, not weeks. Here, the United States Army watches and takes notes. Clipboards in hand. Officers counting seconds. Engineers measuring failures. What they see unsettles them. These machines are not built for the war already raging in Europe. They are built for a war America hoped it would never have to fight. Only months earlier, France had collapsed in 6 weeks. Armored columns had crossed borders faster than diplomats could react. And now, standing on American soil, it is clear this nation has factories, steel, engines, and manpower, but does not have tanks. What follows is not a story of battlefield brilliance. It is a story of urgency, of industrial logic forced into war, of how time, not firepower, became America's greatest enemy, and how a car company would be asked to solve it. The question now is not whether America can build a tank, but whether it can build enough before the war arrives at its door. In 1939, the United States possessed one of the largest industrial economies on Earth, yet one of the weakest armored forces among major powers. This was not an accident. It was the result of doctrine, distance, and a deep belief that oceans were still weapons. For most of the interwar period, American military planners did not see tanks as independent instruments of decision. They were support tools, machines meant to assist infantry, not lead wars. The trauma of the First World War still shaped thinking. Tanks have been slow, unreliable, and expensive. The U.S. Army, limited by budgets and politics, invested cautiously. In September 1939, when Germany invaded Poland, the U.S. Army had fewer than 400 tanks deemed usable for combat. Most were light tanks, M1S and M2S, with thin armor and small caliber guns. They were suitable for training, reconnaissance, and little else. Heavy tanks did not exist in any meaningful number. Medium tanks existed mostly on paper. Across Europe, the picture could not have been more different. German panzer divisions combined speed, radios, artillery coordination, and air support. Tanks were not isolated machines. They were nodes in a system. When German armor rolled through Poland and later through the Low Countries in France, It did not win by sheer numbers alone. It won by tempo. Decisions were made faster than enemies could respond. The fall of France in May and June 1940 changed everything. In 6 weeks, a nation that had fielded one of the largest armies in the world collapsed. French tanks, many of them individually superior in armor and firepower to German panzers, were scattered, poorly coordinated, and doctrinally misused. They fought bravely, but alone. The lesson was brutal and unmistakable. Modern war rewarded systems, not individual excellence. In Washington, the shock was immediate. Army Chief of Staff General George C. Marshall understood what the public did not yet want to accept. The Atlantic Ocean no longer guaranteed safety. Air power had shrunk distance. Submarines erased isolation. And if Britain fell, the United States would stand alone against an industrialized Axis. Yet America, in 1940, was still not at war. Congress hesitated. Isolationist sentiment remained powerful. Military budgets, though increasing, lagged behind reality. The Army ranked 17th in the world in size, behind Portugal. Training units lacked modern equipment. Armored formations existed largely as experimental concepts. Even the idea of an armored force was new. It was only in July 1940, after France had already fallen, that the U.S. Army officially created the armored force as a separate branch, headquartered at Fort Knox. Until then, tanks had been split between infantry and cavalry interests, each pulling design and doctrine in different directions. Now, suddenly, there was unity, but almost nothing to unify around. Designers faced impossible constraints. Any new tank had to be built fast. It had to be transportable by rail and ship. It had to be reliable enough for mass training. It had to be simple enough to be produced by factories that had never built armored vehicles before. And it had to be ready before the United States entered a war it was already preparing for. Meanwhile, Britain was bleeding. By late 1940, British forces had lost thousands of tanks in France. Their factories were under constant threat from German bombers. British purchasing commissions crossed the Atlantic with urgency in their voices and contracts in their hands. They were not asking for perfection. They were asking for anything that could fight. This pressure reshaped American thinking. If the United States could not match Germany tank for tank in tactical sophistication, it could outbuild them. The country still possessed something Europe no longer did: untouched factories, vast supply chains, and an automotive industry accustomed to producing millions of machines to standardized designs. The problem was time. Military arsenals could not scale fast enough. Traditional defense contractors lacked the capacity. What was needed was an industrial transformation, one that treated tanks not as handcrafted weapons, but as products. Somewhere between Detroit and Washington, a radical idea began to take shape: build tanks the way America built cars. And once that idea was spoken aloud, attention inevitably turned to the men and factories that had already mastered mass production, setting the stage for a partnership that would redefine armored warfare before a single Sherman ever reached the battlefield. By late 1940, the United States was racing itself. The Ordnance Department had already accepted an uncomfortable truth. A perfect tank delivered too late was useless. What mattered now was speed, of design, of tooling, of output. The first answer to this urgency was not the Sherman, but a compromised machine born under pressure. The M3 medium tank, known to the British as the Lee and the Grant, was an interim solution. It mounted a 75mm gun, but not in a rotating turret. Instead, the gun sat in a side-mounted sponson, a design that looked outdated even before it entered service. The turret carried a smaller gun. The silhouette was tall, the layout awkward, but could be built quickly. Factories that had never produced tanks before could adapt to the M3's design without waiting for complex turret rings or new casting techniques. By early 1941, M3s were rolling off American lines and shipping directly to British forces fighting in North Africa. There, against Italian armor and early German units, the M3 proved something crucial. American tanks could fight. They were not elegant. They were not refined. But they were reliable, mechanically sound, and available in numbers. For the first time, the U.S. Army saw confirmation that industrial logic could compensate for doctrinal inexperience. Still, the M3 was never meant to last. Even as production began, engineers worked on its successor, a true medium tank with a fully rotating turret carrying the same 75mm gun. This design would become the M4. The requirements were conservative by necessity. Armor thickness was balanced against weight limits dictated by bridges, rail cars, and landing craft. The gun was chosen not because it could defeat every enemy tank, but because it could fire high-explosive shells effectively against infantry, guns, and fortifications. Reliability mattered more than theoretical superiority. Every decision was shaped by one reality. This tank would be built by the tens of thousands. That reality forced the Army to look beyond traditional arsenals. Companies like Chrysler were already being brought in, converting automobile plants into tank factories. But even that would not be enough. The scale required was unprecedented. In 1940, the United States had produced fewer than 400 tanks of all types. War planners were now discussing annual production goals in the tens of thousands. This was not a military challenge alone. It was an industrial one. Few men understood that world better than Henry Ford. Ford had revolutionized manufacturing decades earlier. The moving assembly line, standardized parts, and relentless focus on output had reshaped global industry. By 1940, Ford Motor Company operated vast plants, employed hundreds of thousands of workers, and possessed an organizational culture built around speed and volume. Yet Ford himself was a complicated figure. He was publicly anti-war, suspicious of government contracts, deeply isolationist in sentiment. But events were overtaking ideology. The fall of France, the Battle of Britain, and the expanding Axis threat made non-involvement increasingly untenable. Quiet negotiations began. The government did not ask Ford to design a tank. That work was already underway. What it needed was something else. Ford's ability to turn drawings into metal at a scale no one else could match. The concept was simple and radical. Instead of treating tanks as precision-crafted military machines, Ford would treat them like automobiles. Subassemblies would move down lines. Components would be standardized. Delays would be eliminated. Skilled labor would be supplemented by repeatable processes. This approach alarmed traditionalists. Tanks were weapons. Lives depended on them. Many officers worried that speed would come at the cost of quality. But time was the enemy now, and time favored Germany. By early 1941, the decision was effectively made. Ford would be brought into the armored program, not as a subcontractor, but as a central pillar of American tank production. The M4 Sherman was still months away from mass production. Its design was not yet frozen, its battlefield role not yet proven, but its future was already being shaped, not by generals or tacticians, but by conveyor belts, blueprints, and the relentless logic of American industry. And as factories prepared to retool, the war was about to test whether this logic could survive contact with reality. In 1941, most American tank crews had never seen combat. Many had never even fired a tank gun outside of training ranges. They learned their trade in wide American fields, far from artillery and enemy air power, practicing maneuvers against imaginary opponents. Inside the tanks, conditions were harsh even in peace. The interiors were cramped, loud, and unforgiving. Engines overheated. Fumes lingered. Communication relied on shouted commands and early intercom systems that often failed. Crews learned by repetition, not experience, driving, loading, aiming, and repairing the same machines again and again until muscle memory replaced doubt. What these crews lacked in combat knowledge, they made up for in adaptability. They were mechanics as much as soldiers. Tracks broke. Engines stalled. Transmissions failed under stress. American training emphasized maintenance because it had to. A tank that could not move was worse than useless. It was a target. This reality shaped how the M4 Sherman would be built. Designers understood that crews would have limited experience and limited time. Controls needed to be straightforward. Components needed to be accessible. Repairs needed to be possible in the field, under pressure with limited tools. The Sherman would not ask crews to master complexity. It would ask them to survive long enough to learn. The human cost of failure was never theoretical. Reports from Europe described what happened when armor burned. Crews trapped inside, ammunition cooking off, survivors carrying scars that lasted decades. These reports circulated quietly through the Army, reinforcing one priority above all others: reliability. A tank that arrived late or broke down early endangered its crew before the enemy ever fired a shot. American industry approached the tank problem with a different mindset than European powers. Germany and Britain relied on skilled labor, incremental improvements, and relatively small production runs. The United States thought in multiples of shifts, of factories, of output curves. For Ford engineers, the tank was not a weapon first. It was a product. Every design feature was evaluated not only for battlefield performance, but for how easily it could be produced. Curved armor plates were avoided when flat plates would suffice. Cast components were favored when they reduced machining time. Bolt patterns were standardized. Tolerances were set wide enough to allow rapid assembly without constant rework. This philosophy clashed with traditional ordnance culture. Military engineers worried that simplification meant vulnerability, that standardization meant predictability. But the counterargument was ruthless and convincing. A destroyed tank could be replaced. A missing tank could not. Ford's plants began preparing for a scale of production that had never been attempted with armored vehicles. Tooling schedules were compressed. Supply chains were reorganized. Subcontractors were integrated into a single production rhythm. The goal was not excellence, it was consistency. An M4 Sherman built in one factory needed to be functionally identical to one built hundreds of miles away. Crews should be able to move between vehicles without retraining. Spare parts needed to fit everywhere. This was industrial warfare. Every hour saved on the line meant days saved in delivery. Every standardized component meant fewer delays at the front. The battlefield, in this logic, extended back through rail yards, ports, and factories all the way to Detroit. By the time the first Shermans began to take shape, it was already clear that this tank would not be judged by a single duel or engagement. It would be judged by how many could be delivered, how quickly they could be repaired, and how reliably they could keep moving under fire. Yet machines alone do not fight wars. As production accelerated, deeper questions emerged about the design choices being locked in, the leadership willing to accept trade-offs, and the enemy already preparing to face these tanks in combat. Those questions would define the Sherman's reputation long before its legacy was decided. The M4 Sherman was not designed to dominate tank versus tank combat. It was designed to function everywhere all the time. Its armor was sloped, not to maximize thickness, but to improve effective protection without adding weight. The frontal plate was sufficient against most early war threats, but it was never intended to stop every enemy gun. Weight mattered. Every extra ton limited bridge crossings, strained engines, and reduced transport options. The 75mm gun reflected the same logic. It was chosen for versatility, not supremacy. Its high explosive round could destroy anti-tank guns, infantry positions, and light fortifications. In 1941, this mattered more than defeating heavy armor that did not yet exist in large numbers. When heavier German tanks appeared later, the Sherman would adapt, but adaptation was not part of the original requirement. Mechanically, the Sherman emphasized reliability. Engines varied: radial aircraft engines, diesel variants, later automotive designs, but all shared a focus on ease of maintenance. Transmissions were robust. Suspension systems were forgiving. The tank could run for long distances without constant breakdowns, an essential trait in a global war spanning deserts, jungles, and frozen fields. The Sherman was not beautiful. It was logical. Behind every compromise stood officers who understood the consequences. General George C. Marshall pushed relentlessly for expansion, knowing that delays could not be recovered later. The Ordnance Department, often criticized for conservatism, was balancing impossible demands: speed, safety, adaptability, and cost. There was no time for perfect consensus. Once the Sherman's design was frozen, changes became difficult. Tooling had begun. Contracts were signed. Factories were moving. Leadership accepted that some flaws would be carried into battle because fixing them would cost months the Army did not have. This was leadership measured in risk. German intelligence initially dismissed American tanks. Early encounters with the M3 Lee reinforced stereotypes of crude design and tall silhouettes. But perceptions shifted as Shermans appeared in numbers. German crews noted their reliability, their speed, and, most troubling, their presence everywhere. A tank that keeps coming back becomes a strategic problem. German planners understood that even superior weapons could be overwhelmed by consistent opposition. The Sherman was not feared as an individual machine. It was feared as a system, one that could replace losses faster than Germany could inflict them. By the time Shermans reached European shores in force, the war had already entered a new phase, one where industrial capacity began to outweigh tactical brilliance. And as the first mass-produced M4s rolled out of American factories, the experiment of industrialized armored warfare was about to face its first true test. By early 1942, the M4 Sherman was no longer a design. It was a process. Across the United States, factory floors that had once produced sedans and trucks now echoed with the sound of armor plate being welded, bolted, and cast into place. The transition had been abrupt. Tooling arrived in crates. Blueprints replaced marketing posters. Civilian workers, many of them new to heavy industry, were trained to build machines meant for war. Ford's approach was relentless. Tasks were broken down into repeatable actions. Hulls advanced station by station. Turrets were assembled as independent units, then lowered into place. Engines were tested, removed, and reinstalled. Every step was timed. Every delay analyzed. The goal was not innovation. It was flow. This was the assembly line repurposed for survival. The Sherman's design now hardened. Changes were minimized. Components were standardized. If a flaw was discovered, it was weighed not just against battlefield risk, but against the cost of stopping production. In most cases, production won. Numbers began to climb. In 1941, American factories had produced fewer than 5,000 tanks of all types. In 1942, that number would more than triple. Sherman production alone accelerated month by month. Each tank was logged, inspected, and shipped, its destination already assigned before it left the factory. They moved by rail to ports, by ship across dangerous waters, then again by rail or truck to training grounds and fronts still being defined, for crews receiving them. The Sherman was both reassuring and unfamiliar. It started when it was told to start. It moved when commanded. It rarely failed without warning. For soldiers raised on training equipment that often broke down, this mattered. Confidence grew not from firepower, but from trust. The U.S. Army did not yet know how the Sherman would perform against Germany's best armor. That reckoning was still ahead. But the tank was already fulfilling its primary mission, existing in large numbers on time. Britain was the first to commit Shermans to combat. In late 1942, American-built M4s arrived in North Africa under Lend-Lease. There, British crews replaced worn-out equipment with fresh machines straight from American factories. Initial reports were cautiously optimistic. The Sherman's gun handled German Panzer III and IV tanks effectively. Its mobility suited desert warfare. Its mechanical reliability reduced non-combat losses. For American planners, these reports mattered more than press releases. They indicated that the industrial gamble had not failed, at least not yet. At the same time, U.S. forces were preparing for their own debut. Operation Torch, the Allied landings in North Africa in November 1942, will be the first major test of American armored forces against the Germans. Shermans were loaded onto transports alongside men who had never been under fire. Training had been compressed. Doctrine was still evolving. There would be no controlled conditions now. As ships crossed the Atlantic and Mediterranean, planners understood what was at stake. If the Sherman failed catastrophically, there would be no immediate alternative. No reserve design waiting in the wings. Production was already committed. When the ramps dropped in North Africa, the Sherman would face not test ranges or theoretical enemies, but experienced German crews who had been fighting for years. And in that moment, the success or failure of America's industrial solution to war would be decided not by factories, but by fire. November 1942. North Africa. The first American Shermans entered combat not in sweeping maneuvers, but in confusion. Landings scattered units. Communications faltered. Maps proved inaccurate. And waiting inland were German forces hardened by years of war. At places like Kasserine Pass in early 1943, the limits of American readiness were exposed. German panzer units, supported by artillery and coordinated movement, struck U.S. positions with speed and precision. Shermans burned. Crews were killed or forced to abandon their vehicles. Tactical errors compounded technical shortcomings. Inexperienced leadership misused armor, sending tanks forward without adequate infantry or reconnaissance. The shock was severe, but the lesson was not that the Sherman was useless. Where properly employed, the M4 performed as designed. Its 75mm gun could destroy German medium tanks. Its mobility allowed it to reposition quickly. Its radios, standard in every tank, gave American units an advantage in coordination that was not always matched by their opponents. Most importantly, losses could be replaced. Within weeks, new Shermans arrived. Crews trained again. Units reorganized. The industrial pipeline did not stop. German commanders, accustomed to exploiting shortages, found that American formations reappeared faster than expected. This resilience changed the dynamic. By mid-1943, Allied armored units in North Africa had adapted. Combined arms tactics improved. Shermans worked alongside infantry, artillery, and air support. The tank was no longer expected to win alone. German assessments evolved accordingly. Reports noted that while the Sherman was inferior to newer German tanks in armor and gun power, it was reliable, numerous, and well-supported. Engagements became wars of attrition, exactly the kind of conflict Germany could least afford. As the war expanded into Italy and preparations began for the invasion of Western Europe, Sherman production continued unabated. Variants appeared: improved armor, better guns, specialized roles. None altered the core philosophy. Build fast. Build many. Keep them running. By the time Allied forces landed in Normandy in June 1944, the Sherman was everywhere. On beaches, in hedgerows, on roads stretching back to ports overflowing with spare parts and fuel. German heavy tanks could destroy Shermans at long range. This was no secret. Crews knew it. Commanders knew it. But the battlefield reality was stark. Every destroyed Sherman was met by another. The turning point was not a single battle or breakthrough. It was the moment when German forces realized that American industry had transformed into a weapon that did not tire, did not pause, and did not negotiate. The Sherman was no longer just a tank. It was proof that the United States had learned how to fight an industrial war and had committed fully to doing so. And once that commitment became visible on every front, the outcome of the armored war began to shift irreversibly, carrying consequences that would be measured long after the last Sherman rolled forward under fire. By the end of 1943, the numbers told a story no battlefield report could fully capture. American factories were producing tanks at a rate the world had never seen. The M4 Sherman became the backbone of Allied armored forces not because it was the most powerful tank of the war, but because it existed everywhere the war demanded armor to be. From the deserts of North Africa to the hills of Italy, from the hedgerows of France to the islands of the Pacific, Shermans moved with the front. By war's end, more than 49,000 Shermans had been built. This scale reshaped strategy. Allied commanders planned operations, knowing replacements would arrive. Damaged tanks were recovered, repaired, and returned to service in days rather than weeks. Forward repair depots followed advancing armies. Spare parts flowed in volumes that would have been unimaginable to earlier generations of soldiers. Logistics became a form of protection. Crews understood this instinctively. A hit did not always mean finality. Survival rates, while still grim, were improved by escape hatches, reliable radios, and predictable mechanical behavior. The Sherman earned a reputation not for invincibility, but for giving crews a chance. Criticism, however, followed the tank everywhere it went. German heavy tanks like the Panther and Tiger outmatched the Sherman in frontal armor and gunpowder. Encounters often favored the Germans tactically. Post-war narratives would seize on these disparities, reducing the Sherman to a symbol of sacrifice through inferiority. The reality was more complex. The Sherman was never meant to duel heavy tanks alone. When it did, losses occurred. But those losses did not halt operations. The armored force absorbed them, adapted, and continued forward. The tank's true strength lay not in individual engagements, but in sustained momentum. In the Pacific, the Sherman proved especially effective. Against Japanese forces with limited anti-tank capabilities, the M4's firepower and armor dominated the battlefield. Flamethrower variants reduced fortified positions. Infantry support roles came to the forefront, fulfilling the tank's original doctrinal purpose. Across all theaters, the Sherman became familiar. Its silhouette appeared in newsreels, photographs, and letters home. It became a symbol not of technological supremacy, but of American presence, steady, persistent, and increasingly overwhelming. Yet numbers alone do not explain legacy. Behind every production statistic were crews who fought, adapted, and survived or did not. Behind every repaired hull was a system designed to keep war moving forward, regardless of cost. As the war drew toward its final phases, the question was no longer whether the Sherman had succeeded. It was how its method of success, industrial, relentless, and unsentimental, would shape the memory of the war itself. That reckoning would continue long after the guns fell silent. When the war ended in 1945, the M4 Sherman remained in service across the world, its presence extending far beyond the conflict that created it. Allied nations retained thousands of vehicles. Others received them through military aid programs. Some would fight in wars not yet imagined. This longevity forced a reassessment. Critics focused on what the Sherman was not. It was not the most heavily armored tank of the war. It did not mount the largest gun. It did not dominate every engagement. These comparisons, often made in isolation, missed the conditions under which the Sherman had been conceived. It was built for 1941, not 1945. When the design was frozen, German heavy tanks did not yet exist in significant numbers. Air power, logistics, and combined arms doctrine had not yet matured to their later forms. The Sherman evolved within a system already in motion, adapting where possible without halting the flow of production that sustained the war effort. Crew survival became a focal point of post-war analysis. Early ammunition storage practices increased the risk of fire after penetration, a flaw that earned the tank an unfair reputation. Later modifications, including wet stowage, significantly reduced this danger. Statistical reviews showed that survival rates compared favorably to other tanks when doctrine and support were properly applied. The Sherman's greatest contribution was structural. It demonstrated that modern war could no longer be separated from industrial capacity. Strategy depended not just on generals and tactics, but on engineers, factory managers, transport planners, and assembly line workers. Victory was assembled as much as it was fought. For Ford and other manufacturers, the war transformed identity. Factories built for consumer goods became engines of survival. Workers who had never worn uniforms became part of the war effort through repetition and precision. The distance between home front and battlefield narrowed until they became parts of the same machine. The Sherman embodied that machine. It was a tank defined by compromise, but also by clarity of purpose. It accepted limitations in exchange for availability. It traded perfection for presence. And in doing so, it helped ensure that Allied forces could continue advancing, absorbing losses without collapse. As the last Shermans were mothballed or sold off, their legacy settled into something quieter than myth. They were not legends of invincibility. They were instruments of endurance. And that distinction would define how the war was ultimately won, and how it would be remembered by those who understood that victory in the modern age belonged not only to those who fought hardest, but to those who built fastest. The story of the M4 Sherman is a story of industrial courage as much as battlefield bravery. It is a reminder that wars are not fought solely with guns and tactics, but with steel, labor, and timing. One tank, isolated, may burn. 1,000, moving relentlessly down a production line, cannot be stopped. The Sherman was never perfect. It was never meant to be. It carried compromises born of urgency, economics, and necessity. Yet it fulfilled the single, unyielding requirement of 1940 America: to exist in numbers large enough to make a difference, to survive long enough to fight, and to arrive in time when the world could no longer wait. Its legacy lies in the way it redefined the relationship between industry and war. Factories became front lines. Assembly lines became as crucial as artillery barges. Engineers, mechanics, and assembly workers were as integral to victory as the soldiers who drove these tanks into battle. In the crucible of necessity, mass production itself became a weapon, a force multiplier that reshaped modern combat forever. The human element never faded. Crews adapted, learned, and endured inside machines that were not invincible, but reliable. They fought knowing the odds, yet armed with the certainty that replacements were on the way. The Sherman's impact was measured not in the number of enemy tanks it destroyed, but in the persistence it allowed, the momentum it enabled, and the survival it offered. Ultimately, The Sherman teaches a simple truth. In modern war, innovation is important, but scale, reliability, and speed often matter more. It was not the most formidable tank of its era, but it was the tank the world needed at a time when the stakes were highest. And when the last M4 rolled off a factory line, its metal and motion carried with it a lesson for generations to come. In a world consumed by conflict, victory belongs not only to those who fight, but to those who build, sustain, and endure. The Sherman was, in every sense, America's industrial answer to a world at war. A machine forged by necessity, shaped by urgency, and immortalized through its unwavering presence on battlefields across the globe.